So now we're going to finish off the end of this section by talking about polyatomic ions. Polyatomic ions are ions that are a group of atoms with a charge. And so we have a number of these, a number of very important ones that we need to remember. Again, for some of these, I have some mnemonics that will help you to remember these, and I'll show you those as we go. When we incorporate these into our nomenclature, they really function in exactly the same way as ions that are just made up of one atom. All right, so let's start with our first polyatomic. So our first polyatomic is nitrate, Nh4 minus. Now, how can we remember this? So here's our first bad joke of the day. Why do chemists like nitrates so much? Because they're cheaper than day rates. And so if you remember that joke, now when you think of nitrates, you can think of low cost. Now if we look at the word low, low has one consonant sound. The word cost has three consonant sounds. So that first word low, and this is the way it's going to be, each of these is going to represent our charge, -1. The second word, cost, has three consonant sounds, and that's going to represent 3 oxygens. And that's what we can use to remember these. The first element, the nitrogen, we can get from the name of the ion. Then our phrase that we're going to use, the first piece of the phrase will give us the charge, and the second piece of the phrase will give us the number of oxygens. We don't really have to worry about remembering if these are overall positive or negative, because with the exception of one polyatomic ion, all of the polyatomic ions that we learn are negatively charged. So we can now look at phosphate. And what is phosphate? Well, phosphate is a very, very common ion because that's what we see in ATP. That's actually what the P in ATP stands for. So very important for energy. Formula for phosphate, PO4, 3 minus. Now the way we're going to remember this one is to think of another use for phosphates. Phosphates are very commonly used as fertilizers. So who might use a phosphate? That would be a crop farmer. And so in crop farmer, our first word crop, we have 1, 2, 3 consonant sounds for -3, and farmer, 1, 2, 3, 4 consonant sounds for 4 oxygens. And again, the phosphorus comes right from the name. Carbonate, CO3, 2 minus, and we can think of carbonate, carbonation, or a fizzy tonic. So fizzy, 2 consonant sounds, -2. Tonic, 1, 2, 3 consonant sounds, 3 oxygens. And again, the carbon can come right from our name. sulfate. So this one we're going to have to go for a little bit more of a reach to come up with a phrase, but sulfate is SO4 2-. And you could kind of think of sulfate as sulfate. So what is the fate of a sole? And notice the way sole is spelled here, S-O-L-E. It's a type of fish. In fact, it's a type of fish you might eat. So when you think of sulfate, you can think of a fish platter. Fish has 2 consonant sounds for the -2, and platter has 4 consonant sounds for 4 oxygens. Then we have chromate, CrO4 2-. And you could think of chrome that you might find on a car. So we'll use the phrase car fitting. Car, 2 consonant sounds, -2. Fitting, 1, 2, 3, 4 consonant sounds, 4 oxygens. And then the last one in this group is permanganate, Mn4-. And you could think of magnate, which might make you think of an oil magnate. Oil, 1 consonant sound, -1. Magnate, 4 consonant sounds, 4 oxygens. All right, once we know those 6, the next group are going to become pretty straightforward. So our next group are going to be the ITE ones. So you'll notice any of those ended with ATE. So when we go to ITE, we lose 1 oxygen. But the charge is constant. So we had nitrate, NO3-. Nitrite, you might be familiar with nitrites. They're used commonly as preservatives in meats, specifically sodium nitrate. And so we just lose an oxygen, NO2-. Phosphate, PO4 3-. We can have phosphite, PO3 3-. And sulfate could also we could also have sulfite, sulfate, SO4 2-. Sulfite, SO3 2-. Our next group are the hydrogen ions. For these, we add H+. So that means we're not only adding a hydrogen, but we're adding a plus charge. So we could have, for example, hydrogen sulfate. If we know that sulfate is SO4 2-, we're going to add a hydrogen, so it's HSO4. We're also adding the plus, so this becomes -1. Hydrogen sulfite, HSO3-. we could do hydrogen carbonate. That takes us from CO3 2- to HCO3-. Now this one actually also has another name. You may be familiar with this one as bicarbonate. And so hydrogen carbonate, HCO3-, or is what we use as baking soda. And then we have hydrogen phosphate, HPO4 2-, or we can even add a second hydrogen to it and make it dihydrogen phosphate. And that would be H2PO4-. So finally, we have two other polyatomics. I don't have mnemonics for these. These are two that you're just going to have to remember. The first one is C2H3O2-. This is known as acetate. This is one that you're probably familiar with, because if you add a hydrogen to this, you get acetic acid. And acetic acid, you may know, is what gives vinegar its smell and its flavor. And finally, we have Nh4 Plus. And just to draw some attention to this, this is our one polyatomic ion that we have to learn that actually has a positive charge. And this is known as ammonium. So I'm going to stop here. At this point, you should go back to in-class exercise number 4 and complete the 5th question, the one that dealt with putting together formulas for ionic compounds. The same rules that you learned, that you practiced for the first couple problems, are going to apply to these. And so let's just do one. Let's say we needed to do calcium nitrate. So to do calcium nitrate, we look at each ion. We know calcium forms a +2 ion. Nitrate forms a -1 ion. And so how many of each will we need? Well, calcium is +2. In order to get to a total of +2 with nitrate, we need 2 nitrates. So 1 calcium and 2 nitrates. But in order to show 2 nitrates, and so that we know it's the entire nitrate group that we have 2 of, we put parentheses around the nitro group and place a subscript 2. That means the 2 and those parentheses applies to that entire nitrate group. And so that's our formula for calcium nitrate. So again, at this point, you'll want to get that worksheet back out, work through the rest of those. And once you're done with that, we will go over them. And then we'll finish up this chapter by looking at naming covalent or molecular compounds, and then get into some stoichiometry.